Alright, so these are the solutions to Thursday's assignment. I'm going to first start by going over the AP problems and then the book problems, and then there's going to be a couple more examples showing you an alternative way to use a use substitution, which is what number 31, the instructions to number 31 had you doing. So feel free to pause this right now if you just wish to look at these answers and try the problems again, see if you're coming up with them. That's fine. If not, continue to watch the rest of this. There will be an assignment at the end as well, so please make sure if you don't watch or feel the need to watch the whole thing, you can just go right to the end to try the new assignment. Alright, so let's take a look at these AP problems. Alright, for this first one, we're given a function f of t is equal to 1 over t. For what value of t is f prime of t equal to the average rate of change of f on the closed interval from a to b? Again, making a note, t is greater than 0. So here we want f prime of t, to first find that. We could look at this as t to the negative first, so we're going to get a negative 1 times t to the negative second, or negative 1 over t squared. Because it has the word average, the average rate of change is our slope of the secant line, so then this becomes f of b minus f of a over b minus a. We do want to find those values, or at least the expressions, so f of b, because f of t is 1 over t, this becomes 1 over b. F of a is 1 over a. So we're going to go ahead and set these two equal to each other. So then we get negative 1 over t squared is going to equal 1 over b minus 1 over a over b minus a. I'm going to go ahead next. We could really do this at any step. I think it's best to try it here. We're going to simplify this complex fraction by multiplying top and bottom by ab. So we get negative 1 over t squared. This will give me a minus b up top. I'm going to leave the bottom in factored form, so ab times b minus a. And what I really have here are opposites. A minus b is the opposite of b minus a. So if I cross those out, I'll put a negative 1. So we end up with negative 1 over t squared equals negative 1 over ab. Since they're both negative, I could just sort of divide those out. Cross multiply as well, so we could just say ab is equal to t squared. Again, t is greater than 0. So when I go to take the square root, t is just going to equal the positive square root of ab, giving us choice B here. Alright, for 32, we are using the trapezoidal rule approximation. So in order to use this, we have to make sure that our differences between the x values are all the same, and they are. They're only a difference of 1. So to set this up, this integral is going to approximate to be 1/2 times each width here, or the height, which is 1. And then if you remember, I just write the first number once. I'm going to double all of these values and then just have a minus 30 at the very end. So just to write this out, and remember we could use calculators on these problems, so we could just type everything in when we're done. So just want to take the time to carefully write these out, carefully type them into the calculator also. Even include the negatives. And once you type this all in, we just say a minus 30 at the end. It should turn out to be B 32.5. So make sure you type everything in very carefully. Alright, for 34, we are looking at to find h prime of 1. And if you notice here, h of x is equal to a composition of functions here. So that h prime of x, using the chain rule, becomes f prime of g of x times g prime of x. So then h prime of 1 is going to become f prime of g of 1 times g prime of 1. Go back up here, g of 1 is equal to 3, so we get f prime of 3. G prime of 1 is negative 3, so this is just negative 3. Then we need to go back and look. F prime of 3 is negative 5, so we get negative 5 times negative 3, positive 15. Okay, 39, referring to this figure here, notice it's y equals f prime of x. We're looking for the points of inflection our function f has on the interval shown. So f has a point of inflection when f double prime of x, a second derivative, changes signs. So from positive to negative, negative to positive. Well, looking at this graph, f double prime of x is, we're going to be looking for the slopes of the tangent line. So we're going to go ahead and draw in a series of tangent lines and see when they change from being positive to negative or negative to positive. So everything starting at the leftmost set of tangent lines, all of these slopes are positive. After this peak here, they start to become negative, go downhill. So we definitely have one point of inflection here. And it is ever so slightly, but here it's still negative, and then looking over here it's positive, so we have our second point of inflection here. After this peak, it starts to go down again, so we have negative slopes here. So when we have our third point of inflection, the very last leg of the graph here, have positive slopes for the tangent lines. So this is telling us that we have 4 points of inflection from looking at the graph. All right, for 40, we're looking at a graph here, consists of a rectangle and a quarter of a circle from 0 to 4 and 8 to 4. For the rectangle, 1/4 of a circle with radius of 4. The average mean value is what we've been looking at. The average value is that fraction of 1 over b minus a times the integral of a to b times f of f of x dx here. All right, so when we go to write this out, we're looking at 0 to 12. So this is going to become 1 over 12 minus 0 times the integral of 0 to 12 of f of x dx. And then we'll just use the area here, so we're going to get 1/12. Our rectangle has a base of 8 and a height of 4, so that's going to be 8 times 4. Plus the quarter circle is going to be 1/4 pi. Our radius is 4, so squared, giving us 1/12 of 32 plus 4 pi. Type that into your calculator and you should get B 3.714. All right, 41 may have seemed a little confusing when you first go to read it, but our starting point here is looking at this part right here. G of 5 is 7, G of 1 we need to approximate, and then G is the antiderivative of f. Anytime it says that, and we're given 2 values here, we could start with that. So this is the key to figuring this problem out. We're going to start, because we know G of 5, we want to be able to use it in an equation to help us find G of 1. This is the fundamental theorem of calculus, that second theorem that we learned first, and this will be equal to the integral from 1 to 5 of f of x dx. So G of 5 is 7, G of 1 is what we need to find, and then this becomes the integral of 1 to 5 of this cube root of x squared plus 4x. And again, since we're allowed to use our calculators, go ahead and type this integral on your calculator. Pause the video if you want. But you should get 10.882. Now we can find G of 1. I'm just going to say that 7 minus 10.882 is what's going to give us G of 1. And then that is negative 3.882. Which is A. But again, this part right here was the key to answering this problem. Right, for 42, we're given an A of t function here, amount of a certain item produced in a factory. T is the number of hours of production since the beginning of the workday at 8 a.m. What time is the rate of production increasing most rapidly? So the rate of production is actually going to be A prime of t. Now, this isn't too hard to figure out. We could distribute the 48 and then use the chain rule here. You could type this into the calculator as well, but if we take the derivative here, that's just going to be 0. 48t, the derivative is going to be 48. 48 times negative 3 is just a constant. And then we can use a chain rule for this last part. So we could say it's minus 12 times t minus 3 squared, and really times the derivative of the inside is 1. But here's our first derivative, and even if we wanted to expand that, we would just get 48 minus 12, we'll get t squared minus 6t plus 9. 48 minus 12t squared plus 72t minus 108. So we get negative 12t squared plus 72t minus 60. We want to know when this rate of production is increasing the most rapidly. So we want to know when this is at a max. Which tells us we need to find our second derivative, which simply becomes minus 24t plus 72. When is this equal to 0? If we just go ahead and solve this, we should get when t equals 3, meaning 3 hours. So 3 hours after 8 a.m. is c, 11 a.m. 44, another function p of t representing population growth. This population will approach a limiting value as time goes on. So what that means is, yes, limits, as t keeps increasing without bound of p of t. When that happens, this last part right here, as t keeps increasing, this is all just going to go to 0. So then this just gives us 6,000. So again, it says population will approach a limiting value as time goes on. During which year will the population reach half of this limiting value? So half of the 6,000 is going to be 3,000. We'll go ahead and set that back equal to p of t. 6,000 minus 5,500 e to the negative 0.159t. And just solve this, subtract 6,000. Or technically you could type this into the calculator. Dividing both sides by the negative 5,500 and simplifying, we actually get positive 6/11. Take the natural log of each side. Oh, 0.159. So t is going to equal the natural log of 6/11 over negative, why do I keep writing 1.59? Negative 0.159, which turns out to be about 3.812. It was asking when or which year, so we could say during the 4th year. Getting C for that. All right, let's take a look at the book problems here. Starting with 14, we need to evaluate this integral using u substitution. So I'm going to go ahead and let u equal just tangent x. And the reason why is because if we let this just equal u squared, if u is just tangent x, when we go to find the derivative over here, we'll get the secant square x, which will divide out with the secant square x that's over here. So then solving for dx, we get du over secant square x. And we'll go ahead and substitute that in. Keep in mind, the limits of integration here are the x values. So when we go to substitute them in, we need to replace the u before we do anything else. So then this becomes the integral, becomes u squared secant square x times du over secant square x. This is where the secant square x's divide out. And we're just left with this, which will become u cubed over 3, but keep in mind x is equaling both of these values as I mentioned before. So at this point, to use them, I want to bring this back in. I'm going to say 1/3 of tangent x cubed. And now x values is what we can plug in. So this becomes tangent of pi over 4 cubed minus tangent of negative pi over 4 cubed. Tangent of pi over 4 is 1. Tangent of negative pi over 4 is negative 1. This will give us 2 and a third of 2, giving us 2/3 here. All right, for 24, the integral from 0 to 7 dx over x plus 2. So I'm going to go ahead and let u equal x plus 2. du over dx is just going to equal 1, so du equals dx. So substituting in here, again we could think of this as the integral 0 to 7 of 1 over x plus 2 dx. So we're going to get 1 over u and then du. So the natural log, the natural log is going to be the antiderivative here. Keep in mind right now it's just the absolute value of u. Again is x equals 0 and 7. So to replace this, we'll have the natural log of x plus 2. And then we get the natural log of 9 minus the natural log of 2. So now we'll get the natural log of 9 over 2, which is approximately 1.504. But leaving it in exact form is okay for this problem. All right, 25. The integral -1 to 3x. I know it says x dx, but we could write it after. It just looks a little bit easier to work with here. So the idea here is, depending on looking at the two, I'm going to go with the bottom because when we take the derivative of x squared, we're going to end up with a 2x. That x will also divide out with this x. So we're going to let u equal x squared plus 1. du over dx is going to equal 2x. So du over 2x is going to equal dx. So substituting in here, -1 to 3 of x over u times du over 2x. These x's now divide out. I could put the 1/2 on the outside, and I get 1 over u du. So this becomes 1 over u times the natural log absolute value of u. Again, x equals -1 to 3. So let's bring back in that x squared plus 1. Now because x squared plus 1 will always be a positive expression, I no longer need the absolute value bars here. So this just becomes natural log of x squared plus 1, -1 to 3. So we get 1/2. Natural log, plugging in or substituting in 3, we'll get a 10 minus the natural log. This will give us a 2. Using properties of logs, this becomes a natural log of 10 divided by 2. So we get 1/2 the natural log of 5, which is approximately 0.805. All right, 28 is next. Integral. Now notice this is an indefinite integral. So what do we need at the end? So if you said plus c, that's right. Again, we could think of this as 1 over square root of 5x plus 8 dx. Let's go ahead and let u equal 5x plus 8. du over dx is going to equal 5. So du over 5 equals dx. So this becomes the integral of 1 over, I'm just going to write this as u to the 1/2, and then it becomes du over 5. So we get 1/5. And I'm also going to change this one more time as u to the -1/2 du. So we get 1/5. Adding 1 or 2 halves here is going to give us u to the +1/2 over 1/2. plus c. Dividing by a half is the same as multiplying by 2, so we're going to get 2/5 u to the 1/2 plus c. Still want to bring this expression that we let u equal back in, so it's 2/5 times the square root of 5x plus 8 plus c. And one more here. So 31 actually leads us into some more examples I'm going to show you. Because the directions here said, make a u substitution and integrate from u of a to u of b. So let's take a look here. I'm going to start the same way. I'm going to let u equal the y plus 1. Now notice because it's using a y, we want du over dy is just going to equal 1, so du equals dy. So substituting back here, we're going to have actually, instead of keeping it 0 and 3, I'm going to change those now. So this is a whole alternative way to do this problem. That way we could keep everything in u. We don't have to bring that y plus 1 back in. So I'm going to say when y is 0, u is y plus 1, so then u is going to equal 1. And then when y is 3, u is going to equal 4. So now this becomes, instead of 0 to 3, it becomes 1 to 4 because these are u's. We don't have to keep writing that in, just pay close attention to what values and variables you're using. So then this becomes u to the 1/2, and then we get du. So now we have u to the 3/2 divided by 3/2, and we're going u equals 1 to u equals 4. This will become 2/3 u to the 3/2, again 1 to 4. So we get 2/3 times 4 to the 3/2 minus 2/3, because we could look at this as distributing that, and then 1 to the 2/3. So remember, when we raise 4 to the 3/2, we're taking the square root of 4, which is 2, and then cubing that, so we're going to get an 8. We're going to get 16/3 minus 2/3, which gives us our answer of 14/3. Just write it over here. All right, so we're going to practice another problem like this, or two, just to show you the two different methods. The first one, I'm going to show you not using this new way and then using the alternative way as well. And from here on, you can choose unless the problems in the book tell you to. I think for the assignment, I'm going to have you just try at least one with the alternative way. Let's take a look at an example here. This is still just 6/2. This is the alternative method of u substitution. Okay, so let's start with 0 to 2 of t times the square root of 1 plus t squared dt. We're going to let u equal to 1 plus t squared. That way now du over dt is going to equal 2t, and then du over 2t becomes, or equals dt. So now this t right here will divide out with the t that's in our denominator. So now this becomes 0 to 2 of t times u to the 1/2, and then du over 2t. Now these t's cross out. We have 0 to 2, u to the 1/2. 1/2 will put out front, and then du. So this becomes 1/2 u to the 3/2 over 3/2. Again, t equals 0, t equals 2. So now we have to bring that expression back in. So we're going to get 1/2, take the reciprocal of that denominator, so it's going to become 2/3 times 1 plus t squared to the 3/2, 0 to 2. So then we'll get Plugging a 2 in here, we'll get a 5, so then 5 to the 3 halves minus 2/3. Putting a 0 in here, we'll get a 1 to the 3 halves. So distributing this 1/2, we're going to get 1/3. 5 to the 3 halves just becomes the square root of 5 cubed, and then this is minus 2/3. Simplifying this, we're just going to get a 5 radical 5. Since they're both over a 3, we could say minus 2 over 3. So we get 5 radical 5 minus 2 over 3. Now, if we tried it a different way, we're replacing this part right here, so the 2 and the 0 are going to change here. So we're going to take a look at when t equals 0, so u is 1 plus t squared, u is going to equal 1, and when t is equal to 2, u equals 5. So then what we would do is at this step right here, this could become 1/2, and we get 2/3 u to the 3 halves, and then we say u equals 1 to u equals 5, and then it takes us directly. So that saves a step or two sometimes as the alternative way, so just kind of cutting that part out. So let's try another problem, but we'll do strictly the alternative way. This is actually from your book. It says page 322, number 36. Negative pi to pi of cosine x over the square root of 4 plus 3 sine x dx. All right, so the question here is, what are we going to let u equal? Most of the time, when we see like a square root, we tend to let u equal the part underneath it. And then here's another good clue as to why, because when we go to take the derivative of sine x, it's going to give us cosine x, so that's going to help us get rid of this cosine x that's in the numerator. So we're going to let u equal 4 plus 3 sine x, and du over dx is going to equal just 3 cosine x. So then du over dx actually du over 3 cosine x is going to equal dx. Now before we do anything else, let's switch the limits of integration. So when x is negative pi, u again is 4 plus 3 sine x, so u equals 4 plus 3 sine of negative pi. Negative pi is just going over to the same, just the opposite way, opposite rotation of going over to pi, so that's going to be 0, so then u equals 4, and then when x equals pi, the same result, u equals 4 plus 3 sine pi, which is going to equal 4. You're going to see the benefit of doing this now. So we're going to have the integral from 4 to 4, right? Cosine x square root, actually this will just be of u, and then we'll have du over 3 cosine x. So cosine x's divide out. I could put the 1/3 out in front. Again, the integral from 4 to 4 of u to the negative 1/2 du. And because I said from 4 to 4, do we even need to do any work? If you remember back to the properties, when these are the same, this just gives you a 0. So that was a benefit, instead of trying to substitute these back in, going through many more steps just to try to get to 0 as well. So give this new method a try. Here are your homework problems. I took a picture of it on the next page, just in case you guys didn't happen to get a chance to take your books home. So these are the problems. So 33 through 35, 37, and try these AP problems. All of these will be no calculator. Again, please let me know if you have any questions. Feel free to send me an email. Good luck, guys.